Today we are going to learn about deploying models with Docker, a beginner's guide. We'll cover how to containerize a machine learning model using Docker, focusing on skills like creating Docker files, managing dependencies, and deploying models efficiently.
Welcome to this beginner's guide on deploying models with Docker. In this video, we'll explore the significance of Docker in the realm of machine learning model deployment. Docker is a powerful tool that enables developers to create, deploy, and run applications in containers. Containers are lightweight, standalone, and executable packages that include everything needed to run a piece of software, including the code, runtime, libraries, and system tools. This ensures consistent environments across development, testing, and production stages, thereby simplifying the deployment process and improving scalability. By the end of this video, you'll gain the skills to create and deploy a Docker container for your machine learning model, understanding the nuances of managing dependencies and exposing model APIs effectively.
Before you can start deploying models with Docker, you need to set it up on your system. To do this, you'll need to install Docker Desktop, which is available for Windows, Mac OS, and Linux. Visit the official Docker website, download the installer for your operating system, and follow the on-screen instructions. Once installed, you can verify the installation by opening a terminal and typing the command Docker version. This command should return the Docker version installed on your machine. Next, familiarize yourself with the Docker command line interface, CLI, which you'll use to interact with Docker. You'll also want to create an account on Docker Hub, a cloud-based repository where Docker images are stored and shared. Finally, configure Docker Desktop according to your development environment. This includes setting resource limits like CPU and memory allocation to ensure optimal performance. With Docker set up on your system, you're ready to start containerizing your machine learning models. The Dockerfile is a critical component in creating a Docker container. It is a text file that contains all the commands needed to assemble an image. A typical Dockerfile for a machine learning model begins with defining a base image. For Python-based models, a popular choice is Python 3.8 Slim, a lightweight version of Python. Next, you'll copy your model files into the Docker image using the copy command. This includes the trained model, any necessary scripts, and configuration files. Following this, you will install the required Python packages using run pip installer requirements.txt, which installs dependencies listed in the requirements.txt file. You can also set environment variables using the env command to ensure that your model runs with the correct configurations. Each instruction in a Dockerfile creates a layer in the Docker image, allowing for efficient updates and version control. By structuring your Dockerfile efficiently, you ensure that your container remains lightweight and performant, paving the way for seamless deployment. With your Dockerfile in place, the next step is to build a Docker image and run it as a container. Start by navigating to the directory containing your Dockerfile. Use the command docker build t-my_model_image. To build the image, the T flag assigns a tag to your image, which is useful for versioning. Once the image is built, you can run it using the docker run command. For example, docker run p5000 to 5000 my_model_image will start the container and map port 5000 on your local machine to port 5000 in the Docker container, allowing you to access the model API locally. Testing the container's functionality is crucial. Open a web browser or use a tool like Postman to send requests to the model's API endpoint and verify its responses. If everything is set up correctly, your model should respond as expected, confirming that your Docker container is running successfully. This process of building and running Docker containers locally allows you to test and debug your setup before deploying it to production. Managing dependencies within Docker is crucial for the smooth operation of your machine learning model. When creating a Docker container, you must ensure that all necessary libraries and dependencies are included. This is typically done using a requirements.txt file, which lists all Python packages needed by your application. Include this file in your Docker context and use the run pip installer requirements.txt command in your Dockerfile to install the packages. Understanding how Docker layers dependencies is essential. Each command in your Dockerfile creates a new layer, and minimizing the number of layers can lead to more efficient builds. For instance, combining multiple run commands into a single line reduces the number of layers. Additionally, to ensure compatibility, it's important to use version-specific dependencies in your requirements.txt. This prevents conflicts and ensures that your model runs consistently across different environments. By effectively managing dependencies, you not only improve the reliability of your Docker container but also facilitate easier maintenance and updates.
Exposing model APIs from a Docker container allows your machine learning model to be accessed over the network. This is achieved by defining the API endpoints in your application code and using the expose command in your Dockerfile. For example, expose 5000 indicates that the application listens on port 5000 within the container. When running the container, use the docker run p option to map this port to a port on your host machine, making the API accessible externally. It's crucial to test the accessibility of these APIs by sending requests to the map port and verifying the responses. Additionally, consider securing your API endpoints to prevent unauthorized access. This can involve implementing authentication mechanisms or using HTTPS for encrypted communication. By properly exposing and securing your model APIs, you ensure that your machine learning model is not only accessible but also protected against potential security threats.
Once your Docker container is running, it's imperative to test the deployed model to ensure it functions correctly. Begin by verifying the model's functionality using a test dataset. Send requests to the model's API endpoint and compare the responses with expected outputs. This helps in identifying any discrepancies in model predictions. Monitoring the container's performance is also crucial. Use Docker's built-in tools to check resource usage, such as CPU and memory consumption, to ensure the container runs efficiently. Additionally, keep an eye out for any error logs or warnings that may indicate deployment issues. Addressing these issues early can prevent potential problems in a production environment. Testing is an ongoing process, and regular checks help maintain the reliability and performance of your deployed model. By thoroughly testing the deployed model in a Docker container, you ensure that it meets the desired performance standards and is ready for production use.
Deploying Docker containers in production environments requires adherence to best practices to ensure efficiency, security, and reliability. First, optimize your Dockerfile by minimizing the number of layers and using a lightweight base image. This reduces the image size and speeds up deployment times. Implementing security measures is crucial. Always use trusted base images and regularly update them to patch vulnerabilities. Consider using Docker's security scanning tools to identify potential risks. Regularly updating your Docker images ensures that your application benefits from the latest features and security patches. In production environments, using orchestration tools like Kubernetes can streamline the management of multiple Docker containers. These tools automate deployment, scaling, and management tasks, making them invaluable for handling complex applications. Finally, monitor the health of your containers using Docker's monitoring tools or third-party solutions. This helps in identifying performance bottlenecks and ensures that your containers operate smoothly. By following these best practices, you can deploy Docker containers in production environments with confidence, maximizing performance while minimizing risks. In conclusion, deploying models with Docker offers numerous benefits, from consistent environments to simplified deployment processes. Throughout this video, we've explored the steps required to create Docker containers for machine learning models, including setting up Docker, creating Dockerfiles, managing dependencies, and testing deployed models. We've also highlighted the importance of securing your model APIs and adhering to best practices in production environments. By mastering these skills, you're well equipped to leverage Docker in your machine learning projects, improving scalability and reliability. We encourage you to continue exploring Docker's capabilities and apply these practices to your future deployments, ensuring success in your machine learning endeavors.